Hello, and here are the notes for properties of parallelograms, section 8.3. In topic 8, we're talking about quadrilaterals. Today is no different, but we're focusing solely on the parallelogram. A parallelogram is a quadrilateral with opposite sides parallel. So on my picture here, I'm going to mark that opposite sides are parallel by using these arrowheads. So you can think of it like a little pointing arrow. Sometimes you'll see it written as a triangle. So if it has one arrow and another side has one arrow, that means those two things are parallel. And let's say on this one I use two arrows. Right, so those two sides are parallel. So my sides with one arrow, that's side BC. When I name a segment, I put the line on top. So BC is parallel to, and then the line on the bottom that it's parallel to is DA. All right, so this little symbol here means is parallel to, in case you've forgotten. So BC is parallel to DA, and then similarly, if we were to write the other pair, the ones that are a little bit more vertical here, like the AB. So AB is parallel to CD. So in a parallelogram, I've got two pairs of parallel sides. A note there, just a reminder of something that is true for all quadrilaterals, is that all angles will have a total sum of 360 degrees. Because I have a parallelogram, I have the following properties that are true. So the first thing first is opposite sides are congruent. So my congruent marks are these kind of straight little lines, right? So opposite sides, so BC is opposite DA. So they are congruent to each other. BC is congruent to DA. And then similarly, AB is congruent to CD. So it is true that they are both parallel, opposite sides are both parallel and congruent. The next piece of information says opposite angles are congruent. So if I focus in on angle B right here, angle B, which is opposite angle D, those will have the same degree measurements. So the measurement of angle B is equal to the measurement of angle D. Similarly for A and C. So the measurement of angle A is equal to the measurement of angle C. Consecutive angles are supplementary. We recently used some of this vocabulary, but let's go over it again verbally. Consecutive angles are angles that are one right after another. They're angles that touch the same side. Supplementary means adds up to 180 degrees. So there's not a way for me to mark this on my picture. Let me use my cursor here. Consecutive angles. So consecutive angles would be like A and B, right? They touch the same side. And supplementary means that they have a sum or they add to 180 degrees. So I can write an equation for that. Measurement of angle A plus the measurement of angle B is equal to 180 degrees. And we have a lot of these combinations. So it's true for A and B. It's also true for B and C, that those two angles add to 180 degrees. Additionally true for C and D. And then to come full circle, same for D and A. So all those facts go with that third bullet point. Consecutive angles are supplementary. And that fourth bullet point is the diagonals bisect each other. Now the diagonals are not drawn in here, all right, but you could draw them in as dashed lines or solid lines. Mine won't be perfect, but you'll get the idea. Diagonals will connect opposite angles. And I'm going to pick a letter here. The point of intersection, let's just call it E. Now, if two lines bisect each other, that means they each get cut in half. So looking at this line BD, right? If it's bisected, then that means that BE is the same length as DE. And they each bisect the other, so that for the other diagonal, you'll also have two congruent halves. So AE would be congruent to CE. That's like the majority of the information. The rest of these notes really just uses that information. Example 1, given parallelogram WXYZ, what is YZ? So I'm looking for this side here. What? Well, let's see. What are things that we know about parallelograms? We know opposite sides are parallel. We also know that opposite sides are congruent. So when I'm talking about this length of YZ, it's going to be the same as WX. Which is 5.09. Okay, example 2, quadrilateral PQRS is a parallelogram. A asks for what is the value of X, and then B says what is the length of each side. So to find the value of X, let's see. I've got 4X on the left side, 7X minus 3 on the top, 5X minus 3 on the bottom, and 2X plus 12. I'm sorry, 5X minus 3 on the right, 2X plus 12 on the bottom. One thing that's important to recognize is when these expressions are written next to the line on the outside, they're most likely referring to the line segment, to the length, okay? If it was referring to an angle, it would be written like kind of close to this angle, or it would have an arrow pointing to the angle. So these all things are representing the sides. Well, we know that opposite sides are parallel. I mean, they are parallel, but they're also congruent. So I've got options here. I can set 7x minus 3 equal to 2x plus 12 and solve. It would also be correct to use 4x equals 5x minus 3. So you could do either one, and either way you'll get the same answer. So when I solve this, I've got 7x on the left and 2x on the right. I want to get all of my x's in one spot. So I move the 2x over by subtracting it. 5x minus 3 is equal to 12. I want x by itself, so I start moving everything away from the x. 5x is equal to 15. Divide by 5. And I'm left with x is equal to 3. If you do the other equation, you will get the same answer. So it works the same. The correct answer is x equals 3. The second part of that says, what is the length of each side? Well, let's see. I've got some things here. I've got PQ, I know is 4x. Right, that's one of the sides. And now I know that x is 3. So 4 times 3 gives me 12. Okay, there's one. Well, let's keep going. I know that QR is equal to 7x minus 3. So I'll replace x with 3. 7 times 3 is 21. 7 minus 3 gives me 18. All right, so this is 12. This is 18. Now you've got two options here to find the other two sides. You could go ahead and you could plug it in for the rest of the expressions. Or you might just recognize, well, if PQ is 12, then doesn't RS have to be 12 because opposite sides are congruent? Mm-hmm. Then you might recognize, oh, well, if QR is 18, then SP must also be 18. So you could plug it in. You have to at least plug in 2 of them, but after that, you should be able to find the other 2 sides. So either way, you choose what works best for you, what makes most sense. Just in case you wanted to see it, let me write out my steps. Great. Given parallelogram ABCD, find the other interior angles. So I'm going to encourage you that to go ahead and pause this video and give this problem a try before it's done for you, before I give you the solution. So just pause this and see what you can find. Okay, let's go ahead and take a look at this problem together. So given parallelogram ABCD, find the other interior angles. So we know 2 things about the interior angles. We know that opposite angles are congruent, and I know that consecutive angles are supplementary. So to use my first fact first, angle C and angle D are opposite each other. So those 2 are going to be congruent. So this is going to be 114 also. Measurement of angle B is equal to 114. Now I'm going to make a little sidebar here. This angle is angle B, but it can be named in different ways. So in this case, this is the only angle at this letter. Sometimes we have to be more specific by using 3 letters to name an angle, and I just want to go over that. So I could also think about tracing this angle right here. So this angle stretches to A and it stretches to C. So I could also name this angle ABC, because as I trace that, I form that angle 114 degrees. So angle ABC. And it could go the other way. So CBA, angle CBA. When you write these angles with 3 letters, the middle letter is always the vertex letter, right? So B is where the vertex is. Just a sidebar, make sure we're very clear on there's different ways to name an angle. All right, so I've got 114, and I want to find this angle here. It's not 114. Check it out. Angle D is obtuse. It's bigger than 90. C is acute. It's smaller than 90. It's likely not going to be the same measurement. So these 2 angles, like D and C, are supplementary, which means they add up to 180. So when I want to find angle C, I'm going to do 180 minus 114. I can't subtract 4 from 0, so I borrow from the 8. 10 minus 4 gives me 6. 7 minus 1 gives me 6. 1 minus 1 is 0. So this angle right here is going to be 66 degrees. And then because A is congruent to C, angle A will also be 66 degrees. Okay, now there are 2 typos in these notes as I have them printed here. So if you have this version, there's 2 typos. And the first one is here in example 4. So please fix this with me. Right here in this expression, angle G is equal to 8x minus 5. This is supposed to be an A. So maybe cross that out and write an A in its place. Given parallelogram GHJK, angle G is 8A minus 5. And angle H is A plus 5. The question is, what is the value of A? Well, let's see what we got. If we go ahead and mark our congruent angles, I've got that G is congruent to J and H is congruent to K. So it might be tempting to take these 2 expressions, A plus 5 and 8A minus 5, and set them equal to each other, but they are not equal, right? H is not congruent to G. These are actually consecutive angles, and they add up to 180 degrees. Okay, so angle G and angle H are supplementary. So I'm going to take those 2 expressions, add them up, set equal to 180 degrees. Now when I have addition in between 2 sets of parentheses, it actually doesn't change anything. So these parentheses are really important depending on the operation I use in between them. For addition, I don't need the parentheses, and it's not going to change anything, so I'm just going to rewrite this without my parentheses. combine like terms and solve. So on the left-hand side, what can I combine? I have an A and an 8A. They're both positive, so when I add them together, I get 9A. I have a +5 and a -5. So those actually cancel and go away completely, right? They're inverses. 9A is equal to 180 degrees. And to solve for A, I divide by 9, divide by 9. 9 goes into 180 20 times. So I'd encourage you to look ahead here, pause this video again, and see if you can find angle G and angle K. All right, so when I come back here, I want to find angle G, and I know that the measurement of angle G is equal to 8A minus 5. I can replace A with my value of A, which is 20. 8 times 20 is 160. Minus 5 gives me 155 for angle G. But I don't have an expression for angle K. Well, you've got a couple of different ways you can go about solving this. I know that H and K are the same. So I could just plug in 20 for H. H is the expression A plus 5. So if I have 20 plus 5, I get 25. The other way I could have done it is I could have just done 180 minus 155 to find the supplementary angle. Either way. That's not my final answer. I don't want angle H, I want angle K. So I'm going to rewrite this. Measurement of angle K is equal to 25 degrees. Definitely want to answer the question that I'm asked. All right, 2 more problem sets. Example 5. For parallelogram GRAM, with MR equal to 39 and PA equals 17, A, what is MP? B, what is GA? When there's no bar written on top of these letters, that means the length of. So let's go ahead and mark what we've got. MR, so this whole diagonal is 39. And PA is 17. So let's go ahead and do part A first. What is MP? Okay, so MP is looking for just this piece of the diagonal. All right, so I've got to go back to what I know about the diagonals. So the diagonals in a parallelogram bisect each other. So I automatically know that this piece is equal to this piece, and this piece is equal to this piece. Well, the whole diagonal MR is 39, and I'm looking for MP. That's just going to be half. So I can take half of a number. So half of 39, all right? That's also 2 into 39. Let's see, 2, subtract, 1, bring down the 9. 9 times 2 is 18 with a 1 left over. Okay, so I have that MP is equal to 19.5 or 19 and a half, which is just half of 39. For the other piece, GA, well, let's see, 17 is just this half, right? Which means that GP is also 17. So you could either do 17 plus 17, or you could do 2 times 17. Either way. But that gives me 34. So GA, the length of the whole diagonal, is going to be 34. All right. Example 6, I need the same fact about the diagonals bisecting each other, but this problem is a little bit more interesting. But this is where my second typo is. So this quadrilateral is not called gram, so cross out the title right there where it says gram and write that as flow. Quadrilateral flow, FLOW, is a parallelogram. If WY is equal to 2x minus 5 and WL is equal to 44, what is x? Okay, so going back to using our facts, I know that this diagonal gets bisected just like this one gets bisected. So that means that 2x minus 5 is going to be the same as 24. So 2x minus 5 is equal to, I'm sorry, 44. I think I misspoke, 44. Let's see, I add 5 to both sides to solve. I get 2x equal to 49. Divide by 2, and I get x is equal to 24 and a half. 24.5. So you could use a calculator, or we can do that with some division. 2 goes into 4 2 times. 2 times 2 is 4. Subtract the 0, bring down the 9. 2 goes into 9 4 times. 4 times 2 is 8. Oops. Subtract, and I'm left with 1. When there's nothing left to bring down, that becomes my fraction. Right? So I can write it as a fraction, or if I want to turn it into a decimal, I'd put a decimal place, drop a 0. 2 goes into 10 5 times. So my value for x is 24.5. All right, last piece. If fy is 4y plus 3, so that's this piece here, 4y plus 3, and OF, the whole diagonal, the whole thing is 10y minus 20, what is fy? I'm going to change my color scheme here. See if we can make a little more sense out of this. Okay, so the green part is just half of this line, right? So if that green part, if Fy is 4y plus 3, wouldn't you agree that Oy could be 4y plus 3 also? Right? And if I added those together, I could get the whole thing. So you could do 4y plus 3 plus 4y plus 3, or you could do 2 times 4y plus 3, right? They both give me the same result. And that is equal to the length of the whole thing, 10y minus 20. Now I have two equations written here, and they're going to give me the same result. Well, I'm just going to pick one to solve. So I'm going to solve the one on the right. 2 times 4y is 8y. 2 times 3 is 6. When I want to move something from one side, I want to get my y's together, so I'll subtract 8y, subtract 8y. 6 is equal to 2y minus 20. Solve for y, so I add the 20 to both sides. And then finally, to get y by itself, I have to divide by 2. Y is equal to 13. Now that doesn't answer my question. The question says, what is Fy? So I need to take y equals 13 and plug that back in. 4 times 13 is 52, plus 3 gives me 55. All right, there we go. Fy is equal to 55, and that will finish up the notes. Thank you very much. Have a great day. Bye-bye.